Welcome to this lesson. That's mathematics lesson. I'm Purity Anzelimo. Our topic is still trigonometry. Trigonometry. And in this lesson, we are going to deal with the last bit in this topic, that is trigonometry 3. And our last bit in this is solving, want to look at solving trigonometric equations. Solving trigonometric equations. That is our last bit in this topic, trigonometry 3. So in our last lesson, we were looking at the transformations. That is whereby we looked at the stretch. We also looked at the translation. And in this we said, when you have a general equation, y is equal to a sine, it can be sine or cos, bx plus c, where a, b, and c are constant. We say that a is the amplitude. A is the amplitude. Then 360 degrees divided by p is the period. Then we have our c all over p, which is the face. We have it as our face angle, and then we have, this is the face angle. Sorry, not the face angle, but the shift angle, not the face angle. We have here the face shift, which is negative. Then we have our C here, which is the face angle. So that's what we have when we have this as our general equation. So in this lesson, we are going to look at now the solution of trigonometric equations. In the previous knowledge, that is in the previous lessons, especially on a topic like algebra, we realized that when we want to solve an algebraic equation, we get one answer. That is the answer is finite. We have finite roots. Finite roots. For example, when you are solving, I have x plus 2 is equal to, for example, maybe is equal to x. When we have such, this is an algebraic equation. When we are solving this, we simply have a half x, we take x to the other side, minus x is equal to negative 2. And therefore, in this, we are going to have negative a half x is equal to negative 2. So we can multiply both sides by negative 2 by negative 2. So this will cancel. We have x is equal to 4. So you can see we have a finite root. Our x is equal to 4. Now in solving trigonometric equations, we can obtain infinite number of roots. We obtain infinite number of roots. And therefore, to ensure that we have a certain answer, we give, all in a question, we are given the range. For example, when we are given the range 0 degrees, maybe for example up to 118 degrees, you only give the roots that are in between here. So when you get an answer like negative 30, you don't include it. When you get an answer, for example, 190 degrees, again, you don't include it. So in this case, for the trigonometric equations, we'll be given the range, and therefore our answers should be within the range. So I want us to do various examples so that you can be in a position to solve the trigonometric equations. And in this case, we are going to look at two methods. And one of the methods will be solving the trigonometric equations by simplifying. So one method will be by simplifying simply whatever we have or evaluating. Then number 2 will also be solving graphically. That is using the graphical method. And I want us to start with the first one, whereby we'll be simplifying, then we can move on to the graphical method. So I'd like to give you a few examples in this. We have examples, can give you like 3 examples. So we are told, number 1, solve the following trigonometric equations. Solve the following trigonometric equations. So in the first one that I want us to start with, we have sine 2x is equal to cos x. And we have been given for the range is from 0 degrees to 360 degrees. So that's what we have, and we are supposed to solve. Here we are simplifying, we are not using the graphs. We can again solve this using the graph, which we are going to do in the next part of the lesson. So we have this, sine 2x is equal to cos x. Our range is from 0 to 360 degrees. And therefore, when you have such, whereby here you have sine and you have cos, we know one thing with the sine and cos, that for the complementary angles, the sine of a certain angle is equal to the cos of that complementary angle. So in this case, we can simply come and say, therefore, sine 2x is the same as cos 90 degrees minus x. It is simply the same. Sorry, not sine, not cos, but again sine. We still have sine here. Sorry, that is sine 2x is equal to this, is the same as sine 90 minus x. That is from our previous knowledge. So we have it as this, and therefore we can simply come, this is our 90 degrees, we can come and get the sine inverse on both sides, on dividing by sine. So in this case, we are going to have, when we get the sine inverse of sine 2x is equal to the sine inverse of sine 90 degrees minus x. So when we have that, we are going therefore to get this as 2x is equal to 90 degrees minus x. So we have therefore 2x is equal to 90 degrees minus x. We want to find the value of x, so we can bring the like terms together. We'll have 2x plus x. 2x plus x is equal to 90 degrees. So we'll have 3x is equal to 90 degrees. Now I want us to be very keen here, because we want to get the answers within this range. As you can see from this, our sign is positive. The sign is positive. The sign, our sign, this trigonometric ratio is positive. And we have seen that we have the first one, which is 90 degrees. Again, we just come and consider the unit circle. We consider the unit circle and consider where the sign is positive. So in the case here, we have the sign here is positive. Again here, the sign is positive. Here it is negative, and also in the fourth quadrant. So in this case here, we have the 90 degrees. That's what we have. So we also need to come and get on the other quadrant. What do we have? So we have 90 degrees. Then here we are going to have, therefore, we have, this is 180 degrees minus theta. Then here we have 180 degrees, then plus, we can now make first x. We have, this is 3x, and therefore we can divide this by 3. by 3 so that we get that acute angle, and therefore our x will be equal to 30 degrees. Now we have 30 degrees here. We have our sine being positive, so we have this and this. So we'll have 30 degrees. We also have another one whereby we have 30. Then here in the second quadrant we have 180 degrees minus 30 degrees. Then we have 150 degrees. Then if we go round once again to come back to this point here, we'll now be having 360 plus 30, which will be outside the limit because it is to 360 degrees. And therefore, our possible answers therefore will be our x is either equal to 30 degrees and also equal to 150 degrees. So that's the solution for x within this range, because when we go once again, we'll get more than 360 degrees. And that's why we say, because we have infinite number of roots, we need to consider the limit that is given. Then we can do another example. Let's do another example. That is part B. We are still solving that the trigonometric equations. We have 2 sine. Here we have x plus 30 degrees is equal to 0.766, and we have been given the range that is from 0 all the way to 360 degrees. So we need to solve that one again. So in that case, this is what we have. So we can first remove these 2 by dividing all through by 2. Dividing through by 2. So when we divide this, we get sine x plus 30 degrees. Then we divide 0.766, we divide it by 2, we get this as 0.383. Then after that, we get the sine inverse on both sides. So we get the sine inverse of the sine x plus 30 degrees, which is equal to now the sine inverse here of 0.383. So in this case now we are going to end up getting x plus 30 degrees is equal to the sine inverse, the shift sign of that answer, which is 22.5 degrees. So that's what we have. And as we can see again in this, our sign is positive. Even from this, the sign here, this is positive, it's not negative. We have it as positive. And therefore, in the unit circle again, we consider where sign is positive. So in that again, we'll come and have our acute angle is 22.5 degrees. So with the unit circle, we have the unit circle. Here the sign is positive. Again here the sign is positive. So we have the first angle, which is 22.5 degrees. So we'll have our x plus 30 degrees being equal to 22.5 degrees. Then we move on. On this side here, we'll have 180 minus our theta. And our theta is 22.5. So we'll have 180 minus 22.5. So in this case, we get 157.5 degrees. Then again, if we move one more round to come back on this side, we'll therefore have the other one as 360 plus 22.5, which will give us 382.5. So here we have 382.5, and we continue. So our x in this case, because now this one is already more than 360, so our x therefore will be, the first one will be, x will be 22.5 minus 30, which will be negative. It will be negative 22.5 minus 30, which will be negative 7.5 degrees. Then the other one will have x plus 30 being equal to 157.5, and therefore our x is 157.5 degrees minus 30. So when we subtract 30 here, we get 127.5 degrees. Then with the other one again, we have x therefore will be 382.5 minus 30 degrees. So we'll have 382.5 minus 30 degrees, we get 352.5 degrees. And therefore our solutions for x, we cannot have this because it is not within the limit. So we'll have therefore 127.5 degrees, and we also have 352.5 degrees. So if we continue, we'll be outside 360. So that's what we have for the solutions. We can do the last example. The last example on this, we can have the following. That is on solving trigonometric equations. So in this one, we have the following. Part C, we have a half tan 2x minus 10 degrees, and we have it as 0.577. So that's what we have in this case, and therefore we require to get the values of x within this, the range we have been given, the range that is up to 360 degrees. 0 degrees up to 360 degrees. So in this again, we can multiply by a half so that we can remove this fraction. So multiplying by 2. We multiply by 2, not a half. Multiplying through by 2. When we multiply this by 2, we'll get tan 2x minus 10 degrees is equal to, we multiply 0.577, we multiply it by 2, and we get 1.154. 1.154. Then the next thing, we need to get the tan inverse on both sides. So we have the tan inverse of tan 2x minus 10 degrees is equal to tan inverse of 1.154. So on this, when we find this, we remain with 2x minus 10 degrees is equal to the shift tan of that, which is 49.1 degrees. Again, in this case, we just do it the same way we've done here. Our tangent here is positive. Our tan is positive, and therefore we need to come and now consider our unit circle. This is our unit circle where tangent is positive. Here we have sine positive, cos positive, and therefore tangent is positive. Here our tangent is negative. Here we have negative and negative, so this is positive again. Here we have negative tangent. And therefore, we consider where the tangent is positive. So our acute angle here is 49.1 degrees. So we'll have therefore 2x minus 10 degrees will be equal to 149.1 degrees. Then in this quadrant here, which is 180 degrees plus theta. So we'll have therefore 180 plus 49.1, and we get 229.1 degrees. Then we can still move on because our limit is up to 360 degrees. So we can come back here, whereby now after another round that is 360 degrees, now we'll have 360 plus 49.1, which is going to be 1904, 409.1 degrees. So if we continue, it will be more than the 360 degrees. And therefore in this, we can reach up to there and therefore say let's see whether we need to continue. Let's move on to the next one and see. We've gotten this as 409.1. Then we are moving direct to this, and therefore we'll have 409.1, then plus 180 degrees, which is 500, because we have here 409.1. This is to here we have 180 degrees, so we'll have plus 180 to get 589.1. So we have 589.1 degrees. We can stop at that and see. So in this case, we'll have 2x minus 10 is equal to 49.1 degrees. So our 2x will be 49.1 degrees plus 10 degrees. We divide by 2. That is for the value of x, divided by 2. So our x therefore will be 49.1. We are adding 10, then we divide by 2. So this will be 29.55 degrees. Then we move on to the second one, whereby we have 2x. Our x in this case will simply be, x will be 229.1 plus 10, we divide by 2. So we'll have 239.1 divided by 2, which is 119.55 degrees. Then again we move on to the other one, our x, which will be 409.1 plus 10 degrees divided by 2. So we have 419.1, we divide by 2, and this will be 209.55 degrees. Then the other one, the last one, in this case we have 589.1 plus 10 degrees divided by 2. So we get 599.1 divided by 2, which will be 299.55 degrees. And therefore we can say, because if we continue again, we'll have a value which is greater than 360, and that is our limit. And therefore our values of x therefore will be, our first x is 29.55 degrees. We also have 119.55 degrees. We also have 209.5 degrees, and we have 299.55 degrees. So those will be those are the values of x within this limit that you've been given here after solving this. So when solving, remember when we have this 2x minus 10, you get the acute angle, you solve it, then you are going now to get the value of x using this 2x is minus 10 is equal to this, you get the value of x. You get all the values of x within the range that is given. So I'd like you to do the following exercise. I'd like you to solve each of the following. Solve each of the following equations in the range. You'll always be given the range. In the range, this is degrees, that is 0 to 360 degrees. For the first part, we have a half sine x is equal to a half. B, we have 2 cos a half x is equal to 1.414. Then we have C, a that sine x plus 30 degrees is equal to 1/3. And finally, number D, we have 2 tan into bracket x minus 15 degrees is equal to 0.7164. So ensure that you solve that. That is one of the methods. This is one of the methods of solving trigonometric equations. And I would like to explain briefly on the second method of solving trigonometric equations. The second method briefly, because we have already plotted so many graphs and therefore this will be very easy. The other method of solving trigonometric equations, number 2, is graphical method. The graphical method, and in this case we'll do one example which will help you on the solving of trigonometric equations by the graphical method or graphically. So in this case, I'd like us to do this one question. This is the question that we've been given on solving that is using the graphical method. So we have, the question is, draw the graph of y is equal to 2 sine x for the value 0 degrees up to 360 degrees. Then on the same axis, draw the graph on the same axis, draw the graph of y is equal to cos x. Hence, solve the equation. The equation is given here. 2 sine x is minus cos x is equal to 0. I'd like us to solve that one. Draw the graph of y is equal to 2 sine x for that range. On the same axis, draw that graph of y is equal to cos x. Hence, solve the equation. 2 sine x minus cos x is equal to 0. So in this case, we are going to plot them each at a time, and we plot them on the same axis. So we can start with the first one, y is equal to 2 sine x. So in this, we simply come, this is what we have. We have our x here, degrees. Then we can have our 2x. And finally, our y, which is equal to 2 sine x. That is, we'll be taking 2 sine. We have here 2 sine x. It is not 2x. It is simply sine x. 2 sine x. Sine y is equal to 2 sine x. That is the value of y, 2 sine x. So we are simply getting the sine of x, then we multiply it by 2 to get the value for our y. So if we start with the 0 degrees, we have the degrees here already, 0. Then we'll move on to 30. We can move on to 60, 90, 120, 150, 180, 210, 240, 270, we have 300, 330, and 360 degrees. So we'll get the sine x here. Then we can also come and get your y, which is equal to cos x. So in this case, we'll be getting cos of this. So we fill that so that we can plot the graphs. So in this, we have 2 sine 0, which should be equal to 0. We have 2 sine 30, which is 1. We have 2 sine 60, which is 1.7. We have 2 sine 90, which is 2. We have 2 sine 120, which is 1.7. We have 2 sine 150, which is 1. We have 2 sine 180, which is 0. We have 2 sine 210, which is negative 1. We have 2 sine 240, which is negative 1.7. 2 sine 270, negative 2. 2 sine 300, negative 1.7. We have 2 sine 330, negative 1. And finally 2 sine 360, which is 0. So we put them to one decimal place. Then we have cos x. So we have cos 0, which is 1. We have cos 30, which is 0.9. We have cos 60, which is 0.5. Cos 90, 0. Cos 120, negative 0.5. Cos 150, negative 0.9. Then we have cos 180, which is negative 1. We have cos 210, which is negative 0.9. Cos 240, which is negative, that is cos 240, which is negative 0.5. We have cos 270, which is 0. We have cos 300, which is 0.5. We have cos 330, which is 0.9. And finally we have cos 360, which is 1.0. Then now we can now plot the graphs, draw the graph, then we can solve the equation from the graph. We are plotting on the same axis, therefore this one we've plotted severally. So we have our y-axis, the highest value in our case here is 1. Our highest value here is 1. Then here we have from 0 to 360 degrees. So in this case we can have 1, 2, 3, 4, 5, 7, 8, 9, 10, 11, 12, 13. So that's what we have. So here we have 0. This is 30 degrees, 60 degrees, 90, 120, 150, 180, 210, 240 degrees. Then we have 270, we have 300, 330, and finally 360 degrees. Then here we also have the highest being 1, 0.5, 1, 1. So we have here 0.5, we have 1, negative 0.5, and we have 1.0. This is 1.0. So that's what we have. We need to plot each graph at a time. So we can start with y is equal to 2 sine x. We have 0, 0. Then we have 30, 1. Our 30, we have 1. We have 60, 1.7. 1.7, somewhere here, sorry. We have up to 1.7. So the highest is 1.7, so we need to add this. This is 1.5, 2. So we have this as 1.5. Here we have 2.0. Again on the other side, we need to add this. We have negative 1.5, negative 2.0. Our highest value is 1.7. That's the largest. So we have 60 degrees. We have 1.7, which is somewhere here. Then we have 90 degrees. We have 2. Actually, our largest is 2, not 1.7. We have 2 here. Then we have 120, 1.7, again here. Then we have 151. We have our 1 here. Then we have 108, we have 0. Then 210, we have -1. So in this case, we have a point that way. Then 240, we have -1.7, which is somewhere here, 1.7. Then 270, we have -270, we have -2, which is here. Then 300, we have -1. We have 300, sorry, we have -1.7, which is here. Then 330, we have -1, which is here. Then finally 360, we have 0. Then we need now to plot that. We need to come and plot that. So we are going to have the following. This is our curve. This is the wave that we are going to obtain. This should be a smooth one. In case you see that it's not smooth, know that there is somewhere where there is a mistake. So after that, we name it. Our y is equal to 2 sine x. Then we move ahead and plot the other one. We have 0, 1. We have it there. Then we have 30. We have 0.9. 30. We have 0.9, almost 1. So it's somewhere here. Then we have 60. We have 0, 1. Then we have 30. 0.9. We have 60. 0.5. 60. We have 0.5. 90, we have 0. 120, we have -0.5, which is somewhere here. Then 150, -0.9. -0.9 is somewhere here. -0.9. Then 180, we have -1. We have, sorry, this is 0.9. For 150, we have 0.9. It should be here. Then for 180, we have -1, which is slightly higher here. Then 210, we have 0.9, which is negative here. Then 240, we have -0.5. -0.5 is somewhere here. Then we have 270, we have 0. Then 300, we have 0.5, which is somewhere here. Then we have 330, 0.9. 0.9, it's somewhere here for 0.9. And finally, we have 360, which is 1, which is somewhere there. So that's what we have. Again, we join the points to get the other curve. So we are going to have it this way. So that's what we have. This is our turning point here. Move on to this point. Then again, we move on to, the point is still there. We move on to 240. We have -0.5, -0.5, and 210, we have -0.9. So this one is the issue, so we have it there. So we are going to have it this way, moving all the way to 270, 270, then this way, all the way to that other point. So that's what we have, and this curve is y is equal to cos x. So that's what we have for the two curves, that is for the two waves. we should ensure that the curve is smooth, and then that's what we have. Then after that we are told to solve. We are solving 2 sine x minus cos x is equal to 0. Now if you look at this, 2 sine x is this and the cos x is this, and therefore we can write this one as 2 sine x therefore is the same as cos x, is equal to cos x. This simply means this 2 sine x is equal to cos x, and therefore we are going to look at the point whereby the curve 2 sine x equals the curve cos x, and this will be at the point of intersection. It is at the point of intersection of the two curves where they intersect. We have one point here and we have another point here. So where they intersect is the solution for this, and therefore our values of x will be, you just come and read the first angle here, this angle, come and read this angle. It may not be very accurate for my case due to this bond. So this is, if this is 30, this is almost 30. So we can see therefore our first x, the value of x will be this value which is here. We can see for example is 28 degrees, around 28 degrees. Then we have the other one, the other point of intersection, which is at this point here, this one here. So you also need to read this point here, this angle, and therefore we also have an angle like around 205 degrees. So that will be the solution for that. We have x equal to 28 degrees and 205 degrees. That is at the point of intersection. At the point of intersection is where we are going to have those values of x. So you need to be more accurate. Since you have the graph paper, you need to be very accurate to ensure that these angles are exact, because you are given a range of maybe plus or minus 0.1. So that's what we have. You read this point and this point, which are the points of intersection. This is a point of intersection. At the point of intersection, this curve is equal to the other. At the point of intersection, again, this curve is equal to the other, and therefore that will give us the solution to that equation. 2 sine x minus cos x is equal to 0. So you can be able to solve more trigonometric equations by the graphical method. That is by drawing the two graphs or the graphs that you have been given. Then after plotting the graphs, you consider the equation and see how we can get the values of x, or the value. It can be 1, 2, or even more. So I'd like you to do this question. I'd like you to draw the following. Draw exercise. In this you are solving by the graphical method. Draw the graphs of y is equal to tan x and y is equal to cos x, y is equal to tan x for the values we have from negative pi radian. This is the same as negative 180 degrees up to pi radians, whereby we have from negative 180 to 180 degrees on the same axis, and use your graphs to solve. Use your graphs to solve tan x minus cos x is equal to 0. Then finally, number 2, draw the graph y is equal to sine 2x plus 30 degrees for the range 0 degrees all the way to 360 degrees. Then by including a straight line, use your graph to solve. Sine 2x plus 30 degrees is equal to 0.8. So in all these questions whereby we are solving by graphical method, after plotting the graph, you need to apply the knowledge on quadratic equations, whereby you are plotting the quadratic curves and then using those curves to solve various equations. So you need to apply the same knowledge here, whereby like in this case, after plotting this, you now come and get the equation that you are told to solve and see, is it a line that you are supposed to plot? Like in this, you are told that it is by including a straight line. So like if we may look at this part here, we have, in our equation, we have y is equal to sine 2x plus 30 degrees. And in this, we have sine 2x plus 30 degrees is equal to 0.8. So we have is equal to 0.8. So you can see these are the same. These and these are the same. And therefore, the graph that you are going to plot, or the line, is a line whereby y is equal to 0.8. So after plotting the curve, let's say you've plotted the curve. Now you need to come and have the line y is equal to 0.8. So where y is equal to 0.8, and then you read these points, where the point of intersection of the line and the curve, and these points will give you the solution. So ensure that you do that, and that has marked the end of this topic, Trigonometry 3. That is on solution of trigonometric equations. Thank you. Have a good moment.